Hey you guys, this is section 2.6, derivatives of inverse functions, okay? Go ahead and write down the FLT right here and press play whenever you're ready, okay? Given a function, you're going to be able to understand the behavior of inverses and find the derivative of an inverse function. So if you haven't noticed, this whole unit is focused on finding a derivative. Okay, you guys are learning all these techniques, right? You're learning the product rule, the quotient rule, the chain rule. You're learning how to take the derivative of an implicit equation. So you're learning all these techniques, but don't forget, derivative just means you're finding the slope of a tangent, aka the instantaneous rate of change, IROC. Okay, it's like the cop scenario. So keep that in mind as you're learning this new idea of, well, how do I find the derivative of an inverse function, right? Okay, so to recap, okay, and don't worry if you forgot or you've never seen this before, all right? So some things that should have come up, but it's okay if it didn't, in IM3 or Algebra 2 or whatever you took previously, is this notion of a one-to-one function, okay? A one-to-one function is a function that passes the vertical line test, VLT, and the horizontal line test, HLT. Okay, so just to quickly recap, if you had a graph, in order to tell if it's a function, you ran like you ran a vertical line test, and you're hoping that this graph only intersects, this line only intersects the graph once. So if you notice, at most, it only intersects once, no matter where you draw that there. So if it passes the vertical line test, you would consider it a function, okay? So if it passes, you would deem it as a function. For every x, there is a unique y. That's the formal definition of it. Okay? Now, if it doesn't pass, it's not a function. Okay? So the horizontal line test, in terms of passing and not passing, it works the same way. So for instance, if you had a function like this, if you ran horizontal lines to test it, you're looking to see how often it intersects, and in every case it only intersects at most once. So we would call that a pass. But what the heck does it mean, right? So if it passes, it tells you that there's an inverse function that exists. Okay? If it doesn't pass, there's no inverse function. That's basically it, okay? So a one-to-one function is a function that passes both at the same time. So you're passing both vertical and horizontal line tests. So to give you some one-to-one functions, think about a cubic function or a line or a cubic function, exponentials, natural logs. There's a few, okay? So, for instance, the inverse of e to the x, the exact opposite of e to the x, is the natural log of x. So they're inverses of each other, okay? The inverse of squaring something is a square root, okay? The inverse of a cube root is just a cubic function. Okay, now I'll give you one more. The inverse of sine is sine inverse of x, okay? When it looks like an exponent of -1, you don't say sine to the -1 of x, you just say sine inverse of x. Okay? And it's not sin. Please don't say sin, okay? Okay, so here's the thing, though. Just something for you to think about. Here's the sine function, okay? Now, obviously, I said sine function, so it passes the vertical line test, but notice how it doesn't pass the horizontal line test, right? Intersects definitely more than once. So why is there an inverse, right? So what happened here, just to give you a quick snippet of why, because we want to be logical with our approach here. So what's happening is, I'll show you through a graph. So the most common one here is x squared, okay? This is obviously a quadratic function, a parabola. I'll put y equals here. As you can tell, this is not a one-to-one function, right? It passes the vertical line test, so we know it's a function, but it doesn't pass the horizontal line test. Intersects more than once here, right? So like y equals 4. Notice how it intersects twice here, right? So why is it that there's an inverse function? So what we do here is mathematicians kind of cheated a little bit, okay? What they did was they said, well, you know what? If we only focus on a certain part of that function, we can make it one-to-one. So what if I just, if this works, there we go. What if I just grade it out and I were to not look at anything less than or equal to 0? Okay, so what if I were to just look at that? Would it pass the horizontal line test? And it would. So this concept here is called restricting the domain. So if you purposely only focus on a certain domain, you will have a one-to-one function. So for instance, if you guys had sine x, right, which is the one that we were working on, if we had sine x, this thing waves forever, right? It goes on and on and on and on. But what if we were to restrict it right at negative pi over 2 and restrict it at pi over 2, okay? If we were to look at the unshaded areas, so let me just kind of cut it off here by the screen. If you notice, just this graph that you're seeing here, it passes the horizontal line test now, which allows you to build an inverse function here, okay? So I don't want you guys to think that it's going against what we're saying here. So these two were allowed to have inverses because we restricted the domain. Okay. Not really a big component of today's lesson. It's just to give you an understanding of why we did what we did there, okay? Okay, so some things that we're going to review. At some point, your teacher taught you how to algebraically find the inverse function. Now, do you remember how to? It's okay if you don't. And then we're going to explore, well, how do we sketch inverse functions and how does it compare? All right, so we're going to go back to Desmos in a second to take a look. So here's my first example for you guys. Go ahead and write it down. Press play when you're ready. Now, a few things here. Again, because, you guys are making video assessments in the future, right? F to the negative 1, you don't say F to the negative 1 of x, okay? You would say F inverse of x. That's how you would read it, okay? F inverse of x. You could also even say the inverse of f of x. That's fine too. But this is more commonly known, okay? All right, so if we want to find the inverse, if you guys remember, the first step to algebraically finding the inverse, or analytically, I should say, is remember that f of x is just fancy for the y coordinate, okay? That's not the first step, but the first step here is to switch your variables. So the y becomes the x, and then the x becomes the y. Okay, that's the very first step. Now, why we do that, I will explain to you guys, okay? All right, and then the next step is, so actually let me write this down. Switch variables. So first step is to switch your variables. Second step, you solve for y. Or in other words, we get y by itself, we isolate y, right? So good first step. And I'll move pretty quickly here because it's just algebra. We're going to go ahead and subtract 2 on both sides. We have x minus 2 equals 3y. And then we're going to divide by the 3. So y here will equal x minus 2 all over 3. The moment y is isolated, we have found our inverse. So what we do here is, instead of y, I'm going to write the inverse of x, right? F inverse of x is equal to x minus 2 all over 3. And there's your inverse. Okay? Hopefully that was a good refresher, but don't worry if you're learning that for the first time, okay? Okay, so we know this, right? We know that when we had f of x, we found out that our inverse came out to what we just solved for here, okay? So I'm going to ask you guys to do a few things. I'm going to ask you guys to find f of g of x and g of f of x, okay? And again, this is more of a review too. So when you're dealing with compositions, again, we're not talking about calculus at all yet, okay? So don't go busting out the chain rule here, okay? We're just finding f of g of x. So what happens here is, here's how I teach my students back in pre-cal. Okay. I'm only going to focus on this one. I noticed that the outside function is an f. So I wrote my f of x first. X, maybe I should highlight that. X will be replaced by a g of x. Okay? So take a look. So kind of like when you guys did the derivative using the limit notation, right? Or the limit definition. You replaced every x with x plus h. So it's along the same lines here. We're going to have f, and for every x that I see, I am going to replace it for a g of x. Okay? That's the logic behind it, okay? So I found f of g of x here, except I kind of need to clean this up a little bit. G of x, by definition, is the inverse, okay? I should have said this at the beginning. Let's assume that g of x is the inverse of f, okay? So what I'm going to do here is I am going to plug in g of x explicitly. So I'm not going to just leave it as g of x here. I am going to call it x minus 2 all over 3. Okay, so take a look at what develops here. If I clean this up, 3 divided by 3 will reduce out. I'm going to be left with the x minus 2 plus 2, which just gives me x. Now, the significance of it, we'll figure it out in a second, okay? So what I want you to do is now I want you to figure out what g of f of x is, okay? So the same process, apply it to g of f of x. Go ahead and pause and press play when you're ready, okay? Okay, so I noticed that the outside function is g, so I'm going to start off with g. Now I could write f inverse of x, but I'm just going to write g just to make it easier. G of x is the quantity x minus 2 all over 3. Okay, I notice that the inside function is being replaced by an f of x. So that's g of f of x equals f of x minus 2 all over 3. And I'll color code this to help you guys out. This is just f of x and f of x. All right, so now I have g of f of x here, which is what I want, but I need to clean up the right-hand side. I know that f of x explicitly is 3x plus 2. Okay. So here's how this develops. 2 minus 2 goes away. I'm going to be left with 3x divided by 3, which is just x. Interesting. Okay. So it's not a coincidence. Okay. Actually, this is how every inverse function behaves. When you compose a function with its inverse, you will always get x. But it's not just a coincidence here. Like, so what if it's x? What does it really mean, right? And I'll show you guys in a second. Okay, so here's what we understood, okay? Whether we found out f of g of x or g of f of x, we noticed that it came out to x, right? So we're going to make the statement here. We're going to say that if g happens to be the inverse of f, or vice versa, we know that f of g of x will equal x. And obviously g of f of x will equal x as well, but I'm not going to write that down, okay? Okay, so think about this here. Let's say we had e to the x. That's probably the easiest one. E to the x, okay? Exponential functions. Okay, so its inverse, we know the inverse of e, or to get rid of e, or the opposite of exponentials, is natural log. So I'm going to go ahead and type that out. Take a look at its behavior. What do you guys notice about e to the x and the natural log of x, right? Pause and play when you're ready. So you'll notice that there's some type of symmetry here, where they kind of mirror each other. But the question is, where's this mirror, right? And you're probably thinking of, I hope, some type of diagonal line, okay? And it's actually y equals x, okay? So if you notice right there, that red and that purple graph are perfect mirror reflections of each other when you reflect it across the y equals x. So the significance, the y equals x is what happens when you compose one function to the other, okay? That x that you get at the end is the mirrored reflection, okay? So even more so, I want you guys to think about what that very first step was, okay? So let's go back real quick. What was the very first step to finding an inverse? Okay, we switch our variables, right? So pretty much every y becomes an x and every x becomes a y. Take a look here. I'm going to pick one random point on e to the x. The most common one is that one right here. Notice how the x value is 0 and the y value is 1. Well, the first step to finding an inverse is to switching your x's and your y's, right? So that means every single point on this red graph, the infinite amount of points that we have on this red graph, all the x's and the y's are switching. And if you switch all of those points and you plot them, you will get the natural log function. But the easiest thing to do is just think about that point. If I switch 0, 1, I would get 1, 0, right? Which is this exact point right there. Okay? So if you in theory had so much time to flip every single x and y coordinate, you would get the mapping of the natural log function. That's the logic behind it, okay? We haven't talked about any calculus just yet. So that's the understanding of inverse functions. They have an understanding where every x and y is switched, okay? And that's a common behavior for inverse functions, okay? So let's see how this develops here. So what if I wanted to find the derivative of an inverse function? Okay, so here's what we're going to do. I have this equation here. I am going to take the derivative, okay, on both sides. Since they're all in terms of x, there's no need for implicit differentiation here, okay? So here we go. I'm going to take care of the right-hand side. The derivative of x is 1, okay? The derivative over here, there's a composition. There is a function inside of the outside function f. So what do you guys do? How do you take the derivative when you have a composition or a function in a function, right? You have to apply the chain rule. Okay, so the chain rule is the derivative of the outside. So that's going to be f prime of the same inside. So I'm going to write g of x times the derivative of the inside. The derivative of g of x we would write as g prime of x. Okay, that is the chain rule. Okay, so we're going to remember that g is the inverse. Okay, g is the inverse of f. So what in this equation represents the derivative of the inverse? Okay, pause and play when you're ready, but I'll ask one more time. What part in this equation represents the derivative of the inverse function? Press play when you're ready. The derivative of the inverse function is this. Okay, so if I'm curious about the derivative of an inverse, I'm going to do my best to isolate it. So what I'm going to do here is I'm going to go ahead and move this guy over to the other side. Okay, so g prime of x, which is the derivative of an inverse function, okay, will be 1 over the derivative of f of g of x. What the heck does that all mean, right? Well, first off, what you guys just did here with me was we were able to derive the derivative of an inverse function through logic, okay? Not just making up rules, all right? So what the heck does that all mean, okay? And it's kind of funny because globally, students have a difficult time with this concept, except my kids, ha ha ha. So follow my lead here, and if you guys do this one particular step, you cannot mess up, okay? Well, you can, but it's virtually impossible, okay? So here we go. What's happening here is, let me cut and paste this so that I don't have to keep scrolling. Okay. What's happening here is, what you're going to do, every time you're dealing with an inverse function and you're asked to finding the derivative, right? What you're going to do here is, you're going to create two sections, f and g. Whatever those two functions are. It won't always be f and g. It could be g and h and k. It really doesn't matter, okay? But it is an understanding that they are inverses of each other. So they will always make a statement that these two functions are inverses, okay? And what you do is you plot an empty point. Okay? So here's the thing. If this is x comma f of x, okay, then this is the inverse, right? So remember, inverse functions, they have their points flipped. So this right here is really f of x, x, which looks very weird. Okay? So let me write it in a way where it's a little bit less confusing for you guys. So if I did x comma, you know what, let me do this. If I start off with g, because I'm finding g prime of x here, okay? I'll color code this so it's easier for you guys. The x coordinate of g will be the same y coordinate of f. So I'm just going to use the same variable but a different color. Okay? So the y coordinate of g, using the wrong colors here, would just be y, right? But the y coordinate of g will be the f coordinate of f. Sorry, the x coordinate of f. So this right here is really a y. Okay? That's to get the formula out of the way. You're not going to see this in your book because it technically isn't the most formal way of explaining it. Okay? Let me show you through an example. It's a lot easier when you're dealing with values. Okay? So just keep that in mind. Here we go. Example 10. I really don't remember why I called it 10. I think it's because I lose track of numbers. But go ahead and write this down. Press play when you're ready. Okay, so suppose you have a parent function f of a parabola where x is non-negative. If g is the inverse of f, find g prime of 4. Okay, so a few things that you need to know. So we have this function f of a parabola. Okay, so what's the equation to get a parabola? Pause and press play when you're ready. So to get a parabola, you need something quadratic, something to the exponent of 2. Parent function just means the most basic one, okay? So you're dealing with f of x here is equal to x squared, all right? Where x is non-negative, okay? So meaning it can't be negative. So you're looking at a picture that looks like this. You have a parabola, okay? But the x values cannot be negative, okay? So I am going to partially erase the negative side. So we just have pretty much everything in the first quadrant here, okay? So if you take a look here, it's 1-to-1. It passes the vertical line test. It passes the horizontal line test. And here is the important part. They made a statement. They tell you that g is the inverse of f. So right away, I'm going to make 2 points. This is what I was talking about, you guys. This step here is what is going to get you guys that point every single time. All right? We're going to list a blank point. All right? Okay, so here we go. They're asking us to find g prime of 4. Okay, now usually when you have a function followed by a parentheses, that value represents what? Right? Pause and play when you're ready. So if they ask for g prime of 4, 4 is going to represent the x coordinate for g. So I'm going to put a 4 right here. Make sure you understand that before we move on. Now, since f and g are inverses of each other, then I know that the y coordinate of f is also 4. Okay? All right, so what's the point of this chart here? I need to know what this is. I'm doing this whole chart for that value right there, okay? Because you guys got to remember, the derivative of an inverse is 1 over f prime of the other value. The other value is going to go in here. All right? So here we go. Here's what you do. We know that we want the y value to come out to 4. Okay, so let's take a look at our equation. I want the y value to come out to 4. Okay, you could probably do this in your head or solve algebraically, but pause and play when you're ready. Find out what x is. Okay, now for those of you that said x equals plus or minus 2, you're correct, but at the beginning it stated that x is non-negative, so the more correct answer would just be positive 2. Okay, so here's what we did. We just figured out that the x-coordinate is 2, which tells me that the y-coordinate of g is also 2. I fill that out, but again, you really don't need that value. The whole point is to get this guy right here, all right? So I put that number in here because usually after every function, it's followed by the x-coordinate. So this is it. The derivative, so g prime of 4 is going to be the same as 1 over f prime of 2. So we just got to do a little bit of work here. I need to figure out what f prime of 2 is. Okay, so I'm all over the place. Here we go. If I know f, go ahead and figure out what f prime of x is. Press play when you're ready. The derivative of x squared is just 2x. Okay, well, now I want to know, well, what's f prime of 2? Because that's what I want here. F prime of 2 will just come out to 4. 2 times 2 is 4. So this here is going to be 1 over 4. Because I just figured out that f prime of 2 is 4. And that's it. Okay? So again, the moment they state that they are inverses of each other, you're going to set up 2 points. And the whole purpose of this chart, if you will, is to find the x-coordinate of f. All right? That'll help you go further. All right? Let's try another one. Here's example 1. As you can tell, I had to go through several textbooks just to get you guys some good examples. Okay? All right. Write it down. Press play when you're ready. So here we have f of x, which is this cubic function here. What is the value of f inverse, the derivative of your inverse of x, when x equals 3? Okay. So you can do a few things here. Did they state that we had inverses? Okay. So although they didn't explicitly say f is the inverse of f inverse, that sounds funny, because they stated this right here, they imply that f has an inverse, all right? Now, people tend to flip out when they have the inverse notation, and here's what I encourage you guys to do. Let's just, let's call g prime of x represent the derivative of our inverse here. Okay, so we're going to declare it, all right? We're going to change f inverse for g. So if I make the statement here, from here on out, I could just use g instead of f inverse. So right away, I'm going to make a chart. Remember, this is the one step that's going to get you guys this problem correct every single time, all right? We're going to put in 2 blank points, okay? We're trying to find g prime of what, right? They wrote it very differently, but what are they asking us to find? G prime of what? They're asking us to find g prime of 3. Okay, so think about it. What does 3 represent here? Press play when you're ready. 3 is the x-coordinate of g. And since they are inverses, I know that 3 will be the y-coordinate of f. All right. What's the whole point of this chart? To figure out this guy. Okay. So here we go. I know that I want my y value to come out to 3. So I need to do a little bit of work to find out what my x is. Okay? So here's the thing with these type of problems, you guys. Almost always you could use mental math here. The first thing you should do is guess your basic numbers, your basic integers. So start off with 0. If x is 0, will I get 3? Okay, definitely not. So you use your basic numbers. If 0 doesn't work, I would probably use plus or a minus 1, plus or a minus 2, and usually that's as far as you need to go. Okay, but press pause. Think about what x value I could plug in here that's going to get me a y value of 3. Okay? Okay, so just by guessing, I think it might be 2. So let's just take a look. 2 cubed here is 8. Okay, 1/4 of 8 is 2. 2 plus 2 is 4, minus 1 is 3. Oh, cool. So again, you don't have to write it out, but if it helps you, do it. So we know that x has to be 2. We did all that mental math for this right here. Okay, now although we don't need to state it, that implies also that the y value of g is also 2. In some cases, you might need to know that, so that's why I'm filling it out every time, okay? But really, remember, the whole chart is to figure out the x-coordinate of f, all right? So the derivative, g prime of 3, is going to be 1 over f prime of that x-coordinate, which is 2. We did all that to fill this in, okay? So now, the calculus part. Here we go. How do I find f prime of 2? Well, first, we got to find f prime of x. Go ahead and find it, and then press play when you're ready. F prime of x is going to be 3/4 x squared plus 1. Okay, if you're not sure how I got that, ask some peers or ask me. Okay, now that I know f prime of x, well, f prime of 2 is going to be 3/4 times 2 squared plus 1. If you evaluate that, you should get 4. Okay, 2 squared is 4, times 3 is 12, divided by 4 is 3, plus 1 is 4. I know I'm moving quickly, but feel free to rewind if you need to, okay? So f prime of 2 comes out to 4, so now I know that this is 4, but don't forget the 1 over. So there you go. G prime of 3 comes out to 1/4. All right, hopefully you guys are getting the hang of the routine here. Let's do a couple more. Okay, go ahead and write this down, example 7. And then press play when you're ready, okay? All right, so they stated that there's an inverse, yay. Let's let g prime of x represent the derivative of the inverse. Okay, so that we can start using g instead of f inverse. Okay, so right away, your first step, that's going to get you this problem every time, is f and g here. We're going to put in 2 blank points. Okay, they're asking us to find g prime of what? Okay, they're asking us to find g prime of 1 here. Okay, what does that tell you guys? How does that help you fill out your chart? Pause and press play. G prime of 1 is going to represent the x-coordinate of g, which then tells me that the y-coordinate of f will also be 1 because they are inverses. And this whole chart is for me to figure out what this x-coordinate is. So I'll write it down here because I don't have space. This is f of x. I want f of x to come out to 1. So I need to come up with an x-coordinate That'll give me 1. Pause here, press play when you're ready. So my first go-to value is obviously 0. 2 times 0 is obviously 0. The cosine of 0, look at that unit circle, you guys. We got to know our trig values, okay? Cosine of 0, pretty much where cosine starts, is 1. So we do get a value of 1 here, okay? So when x is 0, we get a y value of 1. So boom, there we go. So that tells me that the y value of g is also 0, okay? Okay, so g prime of 1 is going to be 1 over f prime of the other value. We did all that work to figure out what goes in there. So it's going to be f prime of 0. All right? So we just need to evaluate this a little bit more. So we need to know what f prime of 0 is. But before we do that, we need to find f prime of x. The derivative of 2x is 2. The derivative of cosine, okay? You guys have your list of derivatives. It's okay to use it, but don't rely on it in the case that we have to take the exam in person, okay? The derivative of cosine is negative sine. Okay, so, wait, why did I write it like that? That's crazy. Okay, so that's just going to be 2, whoa. That wasn't weird at all. Okay, 2 minus sine x. All right, so we want to find out what f prime of 0 is. So 2 minus sine of 0. The sine of 0, pretty much where sine starts. Sine starts at 0. Okay, and if you need a refresher on trig functions, text me. I'll be happy to, okay? 2 minus 0 is just 2. So f prime of 0 is 2. So I know that g prime of 1 is going to be 1/2. All right? Okay, I'm going to breeze on the next few. Now, this one always pops up on every AP exam, okay? And it freaks people out because, well, there's no equation. But actually, they don't realize it, but not having an equation is a lot easier. This is actually the numerical approach, okay? Because there's no equation, nothing to analyze here. So here we go. Example 5004. Okay, write it down, press play when you're ready. Here they tell us that g of 2 is 5, f prime of 5 is 1/2. If f and g are inverses to each other, right there, right away, f, g. Okay, and g prime of 2 equals, so we're trying to find g prime of 2 equals. So what did they give us? What can I fill out in this table here? Well, g prime of 2 represents the x-coordinate for g, which then tells me what? Tells me that the y-coordinate of f is also 2. And I'm doing this whole table to figure out what this value is, okay? Now, they also give us something, right? So normally we would play with an equation, but now we don't have one. But if you notice here, they tell us that g of 2 is 5. So when x is 2, the y value comes out to 5. So they actually give us more information here. So they tell us that the y-coordinate of g is 5. So how does that help us? That tells us that the x-coordinate of f is also 5. Okay, so here we go. G prime of 2 is always going to be 1 over f prime of, in this case, 5. But wait, how do we find a derivative if they don't give us a function, right? It's even easier. They tell us that f prime of 5 is 1/2. So here we go. So f prime of 5 is 1/2. Well, 1 divided by a half, multiplied by a reciprocal, you guys get 2. So g prime of 2 is 2. A lot easier, okay? We just have to kind of know how to read between the lines here. Here's another one for you guys to try. Press play when you're all done, okay, or if you're stuck. Okay, here they stated that h is the inverse of f, so right away I'm going to write f and h. Okay, I have 2 blank points here. I need to find h prime of 2. So 2 represents the x-coordinate of h, which then tells me that the y-coordinate of f is 2 as well. So I need to figure out what the x-coordinate is here to make it come out to 2. This one's pretty easy to spot. Think about what that comes out to. Obviously, it can't be 0, but if x was 1, 1 cubed is 1 plus 1 gives you 2. So that's good. Okay? So h prime of 2 is going to be 1 over f prime of that x-coordinate, 1. Okay? So f prime of 1, first I got to figure out what f prime of x is. The derivative is just 3x squared plus 1. So f prime of 1 will just be 4. Okay, 1 squared is 1 times 3 is 3 plus 1 is 4. So the whole answer here is 1 over 4. All right, hopefully you got that. Okay, here's another one. Try it out. Press play when you're ready. Get the practice in, you guys, okay? Okay, g is the inverse of f, so right away I'm making my table. 2 empty points. Okay, they're asking for g prime of 13. 13 is going to be the x-coordinate of g, but also the y-coordinate of f. Okay, so I need to figure out a value, an x value, that will give me 13 here. In my head, it's definitely not 0. 1 doesn't seem to work. Let's try negative 1. Negative 1 doesn't work. Let's try 2. If I plug in 2, I get 8 plus 14 minus 9. 14 makes 22 minus 9 is 13. Cool. So I found out that when x is 2, I will get a y value of 13. You're not going to do it as fast, okay? Or maybe you are. But take your time. It's not a rush, okay? I'm just trying to make the video shorter, that's all. So I know the y value of g is also 2. So g prime of 13 is going to be 1 over f prime of that x-coordinate. Okay, so I need to find out what f prime of x is, which is 3x squared plus 7. So f prime of 2 is going to be 3 times 2 squared plus 7, which should give me, what, 19, I think? Okay, so g prime of 13 is going to be 1 over 19. Okay, hopefully you're feeling a little bit more confident each time, okay? All right, here is the last one, I promise, okay? Suppose that f of x is the cosine squared of 2x and g of x is the inverse of f. Okay, what is g prime of 1/2? Okay, right away they made a statement that g is the inverse. That allows me to make my chart here. Okay, I'm looking for g prime of 1/2. So 1/2 is going to be the x-coordinate of g, but also the y-coordinate of f since they're inverses. So I need to figure out what x-coordinate will make this come out to 1/2 here, okay? So you got to look back at that trig table or unit circle here, okay? Here's what I would do. Cosine squared of 2x is the same thing as cosine of 2x quantity squared. We talked about that in a previous lesson. I could solve this algebraically here. To get rid of the square, I'm going to square root. Okay? And if you remember, just a quick sidebar here. The square root of 1/2 is the square root of 1 over the square root of 2. Square root of 1 is just 1. If you rationalize this, 1 over radical 2, you will get, well, let me show you how just in case you're freaking out. You multiply by the same radical here. You're going to end up getting radical 2 over radical 4, but radical 4 is just 2. Rad 2 over 2. That's a very common value on the unit circle here, okay? Now, technically, this is plus or minus, but they did make a statement that g of x has to be somewhere in between 0 and pi over 4. Okay. The cosine of what gives me rad 2 over 2, right? If you look at your unit circle, actually, let me pull it up. Let me see if I have it. Oh, yay. Cool. Here we go. So let me write it out again, okay? So we had plus or minus radical 2 over 2 is equal to cosine of 2x. Okay. We don't need to deal with the negative because they told us that we have to be pretty much from 0 to pi over 4, meaning that we're always in the first quadrant, okay? So really, I'm only looking at this section right here, okay? Remember that cosine represents the x coordinates on this unit circle here. I know that the cosine of pi over 4 gives me a radical 2 over 2 right here. Okay? So what that tells me is that 2x has to equal pi over 4. Don't get caught up with this entire lesson based on just this problem here, okay? It's just a little bit of a review with trig. So we can now say that 2x has to come out to pi over 4, okay? Or if I solve for this, if I divide by 2 and I multiply by the reciprocal, if you guys want to do that, x has to be pi over 8 because pi over 4 times the reciprocal will give me pi over 8. Okay? A little bit of work to be done to get that value. But replay that because I know I moved a little bit quickly. Replay that a couple times until you get it. Okay, so I'm going to go back. Okay, so now we know that x is pi over 8. We did all that to figure this out. Right here. All right, so g prime of 1/2 is going to be 1 over f prime of pi over 8. All right, now here I'm going to move pretty quickly because I'm running out of time. My kids are about to wake up. Okay, if f of x is cosine squared of 2x, or in this case, I'll write it as cosine 2x quantity squared, I need to find the derivative. This right here, I have a function inside of another function. Actually, I have 2 rounds of it, okay? So I'm going to have to apply the chain rule. Derivative of the outside, which is 2 of something to the first power. I'll color code it to help you guys out. Derivative of the outside of the same inside times derivative of the inside. Okay, so sidebar real quick. Just look at the inside. Okay, how do I take the derivative of this? There's also another function inside of another function. So I have to apply the derivative, which is going to be the derivative of the outside, which is negative sine x, or sorry, negative sine. That's the derivative of the outside of the same inside, 2x, times derivative of the inside, 2. Okay, so I'm going to copy paste that guy right there. Actually, I think I could move it right there. All right, let me get rid of all of these arrows here. Okay, all that, f prime of pi over 8, okay, I'm going to get 2 times the cosine of 2 times pi over 8, which is just pi over 4, times negative sine of 2 times pi over 8, which is pi over 4, times 2. It's messy, but who cares? Here we go. Cosine of pi over 4 is rad 2 over 2. Okay. Sine of pi over 4 is rad 2 over 2, but there's a negative in the front there, so I'll put negative rad 2 over 2 times the 2. 2 divided by 2, 2 divided by 2, cancels out. Radical 2 times a negative radical 2 is a negative radical 4, which is negative 2. All that, I know. So my final answer is negative 1/2. So sometimes it gets a little heavy with the algebra. But I'm very confident that you guys have the inverse part down, the derivative of an inverse. So remember, make a chart. Anytime it states that there's an inverse, implicitly or explicitly. And then remember, the whole chart is to get the x-coordinate of f. And once you do a little bit of calculus. All right? We'll stop there. There's some delta math work that you're going to have to do along with your book work. So look out for that, okay? Practice. Reach out to me if you guys need to, okay?